Have you ever just stopped to actually look at the digital maps on your screen? And I mean, really look at them, not just as, simple pictures of the world, but as these highly engineered futuristic information systems? Well, today in this explainer, we're doing a complete teardown of the cartography system. We're going to look under the hood to see exactly how maps form this incredibly powerful interface between our physical environment and our minds. So, let's dive right in.
Here's our roadmap for today's system scan. First, the anatomy of a map. Then, dynamic map ecosystems. Third, the psychology of map design. Fourth, the dark mode revolution. And we'll wrap up with cartography and augmented reality.
All right, section 1, the anatomy of a map, the structural skeleton. So check out the contrast here between two fundamental setups of what cartographers call the map face. That's just the area containing the actual graphic content. On the left, we've got a frame map. It's this rigid, regular area bounded by distinct coordinates. It's completely filled with content, basically anchoring us to a specific grid system. But now look on the right. This is what we call an island map. Here, the geography, in this case Germany, is totally isolated. It's floating freely without that strict rectangular border. And the choice between these two, it completely changes how our eyes unconsciously process the geographic limits of the data. It's a totally different vibe.
Now, surrounding that map face is often a map frame. Notice how this frame uses grid lines and grid points, which are usually represented by those little crosses you see. These absolutely aren't just aesthetic choices made by a designer. They are the literal mathematical skeleton of the map. They let users estimate point coordinates and instantly measure distances right in the middle of the map face. It essentially anchors our spatial awareness in cold, hard math. And finally, we have the map margin. Think of this as the metadata readout panel placed just outside the frame. It holds all the nitty-gritty stuff: title, scale, orientation, legend, coordinate system, copyright. But here's a really fascinating detail. How necessary this data is depends entirely on what the map is actually for. Take a television weather map, for example. The designer minimizes this margin to absolute zero. Why? Because that meteorologist is only going to flash it on the screen for about 3 seconds before enthusiastically moving on to your weekend forecast. They need to force your attention entirely onto the core graphic, like that incoming storm, without you getting distracted by coordinate systems or copyright tags.
Moving on to Section 2, Dynamic Map Ecosystems, plugging into data. So when a map plugs into a larger journalistic system, you get an infographic, just like the super detailed one breaking down the Berlin airlift. Infographics are this standalone presentation form that blends maps with charts, text, and images all into one thing. Here, the map actually isn't acting alone. Honestly, it might even play a subordinate role. It's there specifically to localize important places, like showing you those distinct flight corridors, while your eyes simultaneously drawn over to the bar charts showing the cargo tonnage or the illustrations of the planes. It's just this beautifully orchestrated visual harmony.
But what happens when the information is just overwhelmingly complex? Well, that's when we rely on story maps. This is a storytelling interface that guides you through dense information in a highly controlled sequence. It kicks off with a motivating start, maybe a provocative question or a really stunning visual. Then it locks you into a fixed narrative sequence, and this is key because it drastically boosts your memory retention. Because the whole structure is narrative-driven, the cartographic representation itself actually has to be simplified. Designers deliberately strip away those heavy margin elements we just talked about to keep the story relentlessly moving forward. Then we step up to the ultimate high-tech control centers, dashboards. Dashboards are all about exploratory, real-time usage. They're driven by massive, continuously updated geodata streams, combining maps with interactive widgets so you can make well-founded decisions on the fly. Whether it's monitoring global health crises like the COVID-19 pandemic or analyzing massive sets of urban mobility data, these interfaces let you actively probe and manipulate the data. You aren't just passively consuming a fixed story anymore. You're in the driver's seat.
Let's look at Section 3, Psychology of Map Design, Hacking Human Perception.
To make sense of all this overwhelming data, cartographers rely heavily on Gestalt factors, basically the psychological laws of human perception. They are literally hacking human perception here. The first one is the law of proximity. This states that elements spatially close to each other are automatically perceived by our brains as belonging together. It's kind of like an insider secret in cartography. By deliberately grouping related visual data, like, say, placing a legend right next to the relevant map face, designers actively reduce your unwanted eye movements. They make the cognitive processing of the map feel completely effortless.
Next up is the law of similarity. Our brains instantaneously group things that look alike. It's hardwired into us, and it ensures completely intuitive recognition. Think about it, rendering all bodies of water, like lakes, rivers, streams, in identical shades of blue. Or if a map uses abstract symbols, making all capital cities squares and all other cities circles. That instantly creates two distinct psychological groupings in your mind without you having to constantly flick your eyes back and forth to check a legend. It is a literal brain shortcut.
The really crucial point here is how these psychological laws create what's known as the principle of visual hierarchy. Visual hierarchy states that map elements should be ranked by importance, and designers absolutely force our eyes to prioritize critical data by using contrast. Notice how Germany is highlighted with a lighter color tone against the much darker European background? Well, that lighter tone allows for a way stronger contrast when the bold red text for Berlin is dropped right on top of it. Your eye literally has no choice but to look exactly where the cartographer wants it to look.
Next is Section 4, the Dark Mode Revolution, Going Dark. If you compare light and dark modes, it reveals that dark mode is way more than just some slick aesthetic choice for your apps. On modern mobile screens, it reduces the emission of blue light, which directly reduces eye strain for you during those long navigation sessions. But here's an even more fascinating technical detail. On OLED screens, dark mode physically extends your phone's battery life. Because OLED pixels emit their own light, when you switch to dark mode, those pixels literally turn off. They consume absolute zero power when rendering the deep black background of a night map. How cool is that? However, cartographers have to follow some pretty strict optimization rules to make dark mode actually work for human eyes. Believe it or not, you actually have to avoid pure black backgrounds and pure white text. This prevents intense visual halation, that weird glowing effect, and eye fatigue. But even in this inverted, darker color space, a fundamental cartographic rule still applies: the dark is more principle. When displaying data rankings on a map, darker, more saturated colors must still represent higher values or greater density. It just has to make logical sense to our brains.
Finally, Section 5, Cartography in Augmented Reality, Converging Worlds.
We are entirely abandoning the traditional top-down ground plan that has defined cartography for literally centuries. I mean, we all know that universal experience, right? Standing on a street corner, holding your phone flat, and spinning in circles, just trying to figure out which way the little blue dot is pointing. Well, augmented reality cartography solves this by giving you an egocentric perspective, a dynamic view overlaid directly onto your physical reality. Map signs like a bright orange navigation arrow just pop up in the real world to provide crucial information, integrating geographical data perfectly right into your actual line of sight. But the processing required for this to feel smooth, it is intense. The problem is that your real field of view is usually much larger than what's on the screen, and it is constantly shifting. As you walk, turn, or move your head, AR cartography requires the continuous, real-time dynamic adjustment of all these virtual objects. The map is no longer just a static document sitting on a table. It's a living, breathing tracking system that's updating countless times a second to keep the digital graphics and the physical streets perfectly aligned. So we've gone from the rigid, static grid lines of a map frame to a dynamic digital layer painted seamlessly right over the physical world. And I'm going to leave you with this. When spatial data breaks completely free from the confines of our screens and directly overlays our physical reality, how will it completely redefine the way you experience and navigate your everyday world tomorrow? Definitely think about that the next time you boot up a map. Thanks so much for exploring this interface with me today.